Welcome to Lecture 15. We're talking about circles. Alright, so definition of a circle. So a circle is the set of all points in a plane that are equidistant, which is fancy for saying same distance, from a fixed point called the center. The fixed distance from any point on the circle to the center is called the radius. So one quick thing here, if you're graphing a circle, this is supposed to be a circle, doesn't look that great. Notice, the points that are on the circle are just what's on the radius, or the perimeter. All of the points that are inside, we would not actually consider a part of the circle. They are inside the circle. So when we're talking about an equation of a circle, generally, we're just talking about those values right along the edge that are the exact same distance from the center point. Okay. So there are two different equations for a circle. There's the standard form and the one we're going to look at next. So the standard form of the equation of a circle, if you're given a circle centered at the point, and we'll call that point HK, that's just a generic way to talk about the point, with a radius of r, lowercase r, the standard form of an equation of the circle, also called center radius, is given by the following. X minus h squared plus y minus k squared equals r squared, and small caveat, where r is greater than 0. So, things to point out here. Here is our h and our k. Those are this point here. And then our radius. Now be careful. This is the radius squared, not just r. So notice that there's a 2 there. Now let's take a look at an example. Write the standard form of an equation of a circle with a center, -4, 6, and a radius of 2. Well, let's go ahead, just like when we're writing the equation of a line, we'll copy down the generic equation, x minus h squared plus y minus k squared equals r squared. Now, what do we need to fill this out? Well, remember, the name of this form, which is what I tend to like to call it, is the center radius. So to fill this equation out, we need a center and a radius. And notice they give us both of those. They give us the radius of 2, and then they give us a center of -4 and 6. Let me go ahead and label these. So r equals 2, and then this is my h value, and that is my k value. So let's go ahead and plug those in. H we are replacing with -4, and k is being replaced with 6. Then r is replaced with 2. So plugging those values in to get the equation of my circle, I have x minus -4 squared plus y minus 6 squared equals 2 squared. I could simplify this out a little bit and write it as x plus 4 squared, simplifying that double negative there, plus y minus 6 squared equals 4. And there we have the center radius form of a circle. Now the super nice thing about this form is you can easily pick off the center and the radius of your circle, which is why this form is often the preferred form. But as I said, there is another version, and we'll take a look at it in a sec. So now let's graph the circle. So the way I like to graph a circle is first do the center. So what was the center? It was -4, 6. So let's plot that. -4, 1, 2, 3, 4. And then up 6. 1, 2, 3, 4, 5, 6. There we go. And I'll just label it with a C. You could write the point, but if you write C, that's perfectly fine. Now, we need to find the rest of the circle, so the points on the outside. How do we find that? Well, let's use our radius. So remember, our radius is not 4. It's the square root of that, which was 2, which we were given previously. So r is 2. What I like to do is I like to just use sort of the compass directions, right? Go up 2, 1, 2. And then, actually, I'm going to change colors here. Up 2, 1, 2. Right 2, 1, 2, left 2, 1, 2, and down 2, 1, 2. And then use that to just draw in my circle. As circular as possible. It doesn't have to be perfect, but it should look like a circle. So don't try, if you do something like this, that doesn't look like a circle was being attempted. So please make sure to make it look like a circle as best as possible. Should be nice curves near each point. Alright, and there we go. We've graphed the equation of a circle. Now let's take a look at example 2. Write the standard form of an equation of a circle with endpoints of a diameter -1, 0, and 3, 4. Okay, well, in order to write the standard form of the equation of a circle, which is also, remember, center radius, I need a center and a radius, and I am not given either of those. But there should always be a way to find out what you need to by what's given. So let's just draw a quick sketch. We have our coordinate plane, and we have, let's see, -1, 0 is one diameter, and 3, 4 is the other. So 1, 2, 3, 1, 2, 3, 4. So this is the diameter. What does diameter mean? Diameter perfectly goes from one end of my circle to the other. So we know it looks generally something like this. Now remember, I'm trying to find my center and my radius. Let's think of any ways to find that. I know the center should be directly in between my diameter. It should be the midpoint of my diameter. Do I know how to find the midpoint between 2 points? I do. Let's use the midpoint formula. So to find to find center, we're going to use the midpoint between our two values, so -1, 0 and 3, 4. When we find the midpoint, that is also going to be the center of our circle. So finding the midpoint, let's add together the x values, so -1 plus 3, divide that by 2. Add together the y values, that's 0 plus 4, divide that by 2. And we get 2 divided by 2, 4 divided by 2, which simplifies to 1, 2. So my center is 1, 2. Awesome. We found the center. What else do we need to find? We need to find the radius. So the radius, that is the distance from this point to this point, or the distance from that one to this one. Well, we could use the distance formula and just find the distance between either one of these. So let's just see. I like to use smallest numbers possible, so let's find the distance from the center to this point here. Notice if I did it from the other direction, it would give me the same thing. Let's see. Okay, so let's find the radius. So we're going to find the distance. So the radius is going to equal the distance between 1, 0 and our center. So plugging that, we're using the points -1, 0 and 1, 2. Let's plug those into the distance formula. Subtracting the x values, -1 minus 1, square that, plus subtract the y values, 0 minus 2, square that. Ooh, I used a capital R. That should be a lowercase r. Careful about upper and lower cases. That'll equal square root of, let's see, -2 squared. Ooh, plus another -2 squared. Square root of 4 plus 4 equals square root of 8. Simplifying that, that's going to equal 2 root 2. Okay, so let's go ahead, and we have now found the center and the radius. Awesome. For equation, we will use x minus h squared plus y minus k squared equals r squared. And let's plug in those values. So my h, my k, and my r. So plugging that in, we have x minus 1 squared plus y minus 2 squared equals and 2 root 2 squared. Now there's always that small debate on should I actually square this out? I would say yes, you should square that out. Some professors wouldn't mind as much, but since that shouldn't be that hard to square, I will ask that you square that out. And that's going to be 2 squared. Let's see, doing that on the side. 2 squared root 2 squared. 4 times 2, which is 8. Alright, not too bad. Sort of fun using a mix of different formulas to find out our radius and our center. Let's look at objective 2. Write the general form of an equation of a circle. So now this is the new form. This is called the general form. Now, the general form is x squared plus y squared plus ax plus by plus c equals 0. So notice the x and the y values only have a positive 1 in front of them. If, for some reason, you had a value, let's say for a 1, and then a value for 2 in front of the x and y, that wouldn't be a circle. If the x squared and the y squared have different values, you're not dealing with a circle anymore. You'd be dealing with something we would call an ellipse, possibly. So make sure they have the same value in front, then you know you're dealing with a circle. And the a, b, and c values, those are all just numbers. And this is called the general form of the equation of a circle, which I would say is normally not as useful, because you can't just pull your center off of this, and you just can't pull off the radius. But let's take a look. Example 3. Write the equation in center radius form. What do you know? So, we're given the general form. But we want to write it in center radius form, which remember is also called standard. So, what we're going to do for this is we're going to use, or make use of completing the square, which we looked at for quadratics. Because notice, the equation for center radius is basically 2 perfect square trinomials added together equal to a number. So our goal is to use completing the square to get this equation, which we don't really like too well because it's not that useful, into something that is useful. We're doing a makeover job. Alright, so let's write down our equation. So in the very beginning, I've noticed something that is not good about our equation. At the moment, we still have the number 2 in front of our x and our y. And remember, we want to have the number 1 in front of x and y. So we got to get rid of that. First step. Let's divide out by 2. Which means we have to divide everyone by 2. Once we divide everyone by 2, we're left with x squared plus y squared minus, let's see, 16x plus 6y plus 45 equals 0. So that was the first step. Make sure x and y are by themselves. Next, we want to set this up for completing the square. So remember, for completing the square, you always move the number that doesn't have a variable to the other side. So let's do that. Subtract the 45 from both sides, and we'll get x squared plus, let's say, okay, I'm going to take this time. When we subtract the 45 to both sides, I'm going to rewrite this, but this time I'm going to group the x and the y values. So take a look at how I do this. I'm going to group the x values together, leave space for that perfect number we're going to add in, and then group the y values together. And once again, leave space for that perfect value. So in case maybe you've forgotten, when we're completing the square, we're trying to find the perfect number here so that when I add it to this equation, it factors perfectly into 2 identical looking binomials. For example, maybe it'll factor into x minus 2, x minus 2. When it factors like that, we can just rewrite it as x minus 2 squared. Which, notice, this looks an awful lot like our center radius form for circles. So that is my goal. I want to get it into perfect binomials squared. Alright, so that was a really quick review. I'm going to tap my way back, deleting this because I don't want to accidentally erase something. Awesome. So, completing the square to get those perfect numbers to add into our equation. And so we don't have to do a bunch of guesswork. We're going to use the formula. So we take our b value, divide that by 2, and then square it. So that's going to equal -8 squared, which is 64. And right there we found the perfect number. This number, once I add it into my equation, will create a perfect square trinomial for the x values. So I'll go ahead and add this in, but oops, I've just unbalanced my equation. I've added a 64. How do I balance my equation out? Well, we'll add 64 to the other side. Balance it out. Okay, now let's take a look at the other one. We've managed to create a perfect square trinomial for the x's, but we have to do it for the y's. Once again, instead of wasting time guessing, let's use the formula. Take our 6 value, divide by 2, and then square it. And we get 3 squared, which is 9. Aha! The perfect number to create a perfect square trinomial. Add that guy in. Oops, I just unbalanced my equation. Gotta add 9 to the other side as well. Alright, lots of colors flying around here. So let's see. Let's rewrite this. X squared minus 16x plus 64 plus y squared plus 6y plus 9 equals, now let's add up all these values together. What do we get? Looks like we get a 28. So I'm actually going to squish these together on the side here a little bit because I'm running out of some room. So it's a -45, and then we added a 64. We added a 9. Okay. So now, remember my goal is to create something that looks like this squared, plus y minus k squared equals my r squared. I want to make 2 perfect squares. So let's factor these and see what we get. So factoring, that's x minus 8 times x minus 8. Ooh, those are identical. And this is y plus 3, y plus 3 equals 28. Awesome, I can rewrite this as x minus 8 squared plus y plus 3 squared equals 28. Look at that, it's perfect. We used completing the square to rewrite this in center radius form. Oh, I didn't even need as much room as I thought it did. Alright, there we go. It is beautiful. Why is this beautiful? Because I can pull off my center and my radius easily from this equation. Way harder to do it from that. Now let's identify the center and radius of this circle. So what would my center be? Okay, this is where you have to be careful. The original equation for a circle is x minus h squared plus y minus k squared equals r squared. Notice this one has the minus sign, which matches here. But my other one does not have the minus sign. So take a moment, try to determine what you think the center is using the formula. So the center is going to be 8, -3. You might be going, what? And if you aren't, awesome. But this is a step that I've noticed confuses some students. So what we want to do is to make sure we have that minus sign, and then we're going to take the number next to the minus sign. In this case, the number next to the minus sign was an 8 for the x. But for y plus 3, there was no minus sign. So 2 ways to look at it. One, you can rewrite this with a minus sign by saying this equals y minus -3, right? That's the same thing. And then what's the number by the negative? Well, a -3. So you could write down the -3. Another way some people like to look at it is just take the opposite. So if I was to look at x minus 8, what's the opposite of -8? Positive 8. And then for the y's, what's the opposite of positive 3? -3. Okay, so please be careful about that, because the original formula is working with negatives. All right. And then r squared. Well, I know that r squared equals 28, but I don't want r squared. I want my radius, which is just r. So to solve for my radius, I need to square root both sides. Remember that plus or minus. Then r is going to equal plus or minus the square root of 28. Can we simplify that? Yeah, that's 4 times 7, so r is going to equal plus or minus 2 root 7. Now, the negative is extraneous because you can't have a negative radius, so we'll just take the positive. So r equals 2 root 7. Okay, graphing this. Let's see, let's graph the center first, which is 8, negative 3. So 1, 2, 3, 4, 5, 6, 7, 8, negative 3. 1, 2, 3. That's the center. Now the radius. Oh, there's a square root in the radius. How am I going to graph that? Well, for graphing, we're not going to be approximate here because it's just a sketch of our graph, so we can approximate what 2 square root of 7 would be. So let's look at what it was before we simplified it. It was the square root of 28. What are the next perfect square roots that are above and below 28? Well, 4 times 4 is 16. How about 5 times 5? That's 25. Ooh, 28 is a little bigger than the square root of 25. Which I know means that the square root of 28 is a little bigger than 5. So now let's try box it out on the next side. What is it smaller than? Well, the next perfect square after 5 would be 6 times 6, which is the square root of 36. Which means that the square root of 28 is a little less than 6. So square root of 28 is roughly between 5 and 6. It's a little closer to 25 though, so I'm going to go with, and what I'm going to do is write r is approximately, for graphing purposes, r is approximately 5.5. Let's just be approximate here. Now notice, this is for graphing. You would not box that as your final answer. This is your answer, because it's the this is the actual one. This is just the approximate for graphing. So let's try graph that. Notice it's going to be falling off the graph a little bit here, so let me extend this. 1, 2, 3. All right, let's graph this. 5.5. 1, 2, 3, 4, 5.5, right there. Next. 1, 2, 3, 4, 5.5, right there. Down. 1, 2, 3, 4, 5.5, right there. 1, 2, 3, 4, 5.5, right there. Like a cheerleading sign. Okay. Graphing this in. Oh no, it's looking kind of horrible, baddish. Not too bad. The iPad doesn't give the grip that a paper does. Okay. Looks okay. Not entirely pleased. I don't think Leonardo da Vinci would think much of that. But alright, there it is. We've graphed it. Roughly a circle. And that is it for this section. Please email me if you have any questions on the homework.